We are now going to talk about inconsistent and dependent systems. Before we do that, though, we want to give you a good understanding of what it is that we're talking about. So we have some definitions. Consistent means that a system has one or more solutions. It could mean they meet in one point, or it could mean that they're the same line. Inconsistent, however, means that there are no solutions. No point makes both lines true at the same time. Dependent means that one value of a solution or point is dependent on the other one. This usually shows up because we have the same line, and so lots of points work for both equations since they're both the same. Anything that makes one true makes the other true. So the given point that we have depends on the x, and that gives us our y. Independent, on the other hand, means that there's only one answer and we can find it either way. The x doesn't really depend on a specific y and the y doesn't depend on a specific x. There's only one point xy that makes all of the equations true. We wanted to show you a graph of what we are looking at. So here we have a consistent independent that meets in one point at the 1 minus 1 line. It has one solution and we express its answer as xy. Here we have the same line on top of itself, and so any point on this line is true. Since it's the same line twice, it's consistent dependent, and there's an infinite number of solutions, which we express in set builder notation as the set of all points x, y, such that y equals mx plus b. Finally, our inconsistent, notice that there are two lines. They're parallel, meaning they'll never cross, and that means there's no solution, which we'll write as a 0 with a line for it, or write out no solution. So what we'd like to do now is to solve some problems so that you can see how to recognize these as you're solving them. So suppose we have the equation 2x minus 3y equals 6, and y equals 2/3 x plus 2. So here what we're going to do is we're going to use substitution since it's already set up for it. We're going to take this one right here, and we're going to plug that in wherever we see the y in the first equation. So 2x minus 3 times 2/3 x plus 2 equals 6. Well, when we distribute the minus 3 through, that gives us 2x minus 2x minus 6 equals 6. Well, 2x minus 2x is 0, and I'm left with the equation minus 6 equals 6. Well, since negative 6 does never equal 6, this means that there's no solution and that this is an inconsistent system. No points will make it true, therefore it doesn't have an answer. On the flip side, if we let y equals 2x minus 3, and 6x minus 3y equals 9, again, we can use substitution. This gives us 6x minus 3 times 2x minus 3 equals 9. Again, we distribute. This gives us 6x minus 6x plus 9 equals 9. Combine like terms, and we get 9 equals 9 when this 6x's cancel out. Since 9 equals 9 all the time, that means that any value of x, that when I double it and subtract 3 to get my y, will make both of these true. Therefore, our answer is the set of all points x, y such that, and I can pick either equation, I usually just pick the first one, y equals 2x minus 3. So that's my answer in set builder notation, and this is a consistent dependent system.